Okay, so this -1 doesn't mean sine to the -1 power, it means inverse sine. So we kind of need to change things around first. You remember from trig, if you want to get rid of sine inverse, you just move the sign to the other side. So this means sine of y equals x. All right. So now, could we do a derivative from here? So derivative of sine is cosine. Angle stays the same. Times derivative of the inside, derivative of y would be dy dx equals the derivative of x, 1. So dy dx is 1 over the cosine of y. Alright, but if you follow along, if you read your book on this at all, it's going to tell you that it wants this derivative in terms of x. So we need to get rid of the y. So I want to bring back our old trig days for a minute. Okay. So an inverse gives you an angle. Okay, if I were going to draw a triangle here, when I say sine of y equals x, so that means my angle is y. We know sine, if you think SOHCAHTOA, opposite over hypotenuse. So this means my opposite side is x, my hypotenuse is 1. How could I find the other side?
A squared, b squared, c squared.
A squared plus b squared equals c squared. So we get the square root of 1 minus x squared for this last side. Alright, so then my question is, dy dx is 1 over the cosine of y. So if I wanted the cosine of y, from angle y, cosine is adjacent over hypotenuse. So what is cosine of y? Square root of 1 minus x squared over 1. Or we could just leave it like that. I'm not going to stress out about radicals in your denominator. You can leave it like this. So that is the derivative of sine inverse. Any questions right now? Let's look at another one. Do you guys want to take a second and see how far you can get with this tangent inverse?
Yeah, sure.
See how far you can go. Very, very similar to what we just. So this means tangent of y equals x. So your derivative of tangent is secant squared y. Derivative of the inside, derivative of y is dy dx. Derivative of x is 1. So dy dx is 1 over secant squared y. If I told you though this had to be in terms of x, think about your triangle. Tangent of y equals x. So tangent is opposite over adjacent. So my opposite side is x, my adjacent is 1. A squared plus b squared equals c squared. So the hypotenuse is the square root of 1 plus x squared. So y dx is 1 over. What is secant?
Radical 1 plus x squared over x.
Over 1. Because it's a reciprocal cosine. So it's hypotenuse over adjacent. But this is secant squared. So if you square that, it drops the radical, and you get 1 over 1 plus x squared.
That's the number answer.
You knew what you meant. Okay, these are actually the definitions of the derivative of inverse trig functions. We just proved those. I think, yeah, not the next slide, but the last one I have on page 214. There is a table at the bottom that tells you the derivative of each inverse trig function. We just proved 2 of them. I think you might have to prove cosine on your homework. And then you can use this table as fact. So I'm not going to make you memorize these. If I were to ask you one on a test or quiz, it would probably be just like working out the sine or the cosine like we did right there. We're not going to place a big emphasis on this, but I did want to show it to you. So let's use that to do example 9. So I want to find a couple derivatives. A, 1 over sine inverse of 1. Okay, you could, or sine inverse of x, excuse me. You could think of this as sine inverse of x to the negative 1 power, but those negative 1s don't cancel. Remember that negative 1 on the sine is saying it's an inverse. So let's think about our chain rule. Chain rule says, when you do your derivative of the outside, so the negative 1 comes down, inside stays the same. Subtract 1 from the power, so it's now the negative 2 power, times derivative of the inside. The derivative of sine inverse of x we found on the first example I did today. So that was 1 over the square root of 1 minus x squared. Okay, so there's different ways you could write this. If you wanted to bring this sine inverse down on the bottom, you're welcome to do so. If you don't, that's also fine. But we can use those now in our derivatives. Questions there? So B. If you remember, arctan is the same thing as saying tangent inverse. So this is x times the tangent inverse of the square root of x, or I'll write that as x to the 1/2. So when I do this derivative, what is the big thing I need to remember? How am I going to do this derivative? What do I have to remember to do? Well, where do we even start? Product rule. There's things multiplied. I have more than one x. I have this times this. So we have to do product rule. So derivative of the first, derivative of x is 1 times the second plus the first, so x, times derivative of the second. So this is not tangent to the negative 1, it's tangent inverse. And we found the derivative of tangent inverse is 1 over 1 plus x squared. Now we have to be a little bit careful. In this formula, x is representing the angle. What's my angle here? Yeah, so what's x to the 1/2 squared? Just x to the first, right? So, the formula for tangent inverse says the derivative of tangent inverse is 1 over 1 plus your angle squared. My angle here is x to the 1/2. Okay, chain rule times derivative of the inside. So the derivative of x to the 1/2 would be what?
1/2 x to the negative.
So if we clean this up a little bit, we have tangent inverse of x to the 1/2, or you can write it as a square root, plus, alright, if I multiply together, what's an x times an x to the negative 1/2? X to the 1/2. So I'll put a 2 on the bottom. Questions? A little bit uglier. All right. That's really the end of this, but I'm happy to do some more examples. Is there anything that you had difficulty with yesterday that you would like to talk about again?
17.
Okay. So 17 is actually going to be this. But let's go ahead and do it together. So we have tangent inverse x squared y plus x plus, or equals, sorry, x plus so let's figure out how to go through and do this derivative. We now know the derivative of tangent inverse, so just kind of keep that in mind. If y is tangent inverse of x, the derivative of that is, what did we get? Okay, so this is kind of what we found, which is the piece that we need to be able to go through and do this. So let's start on the outside. Derivative of the outside. This is tangent inverse. So we know the derivative of tangent inverse is 1 over 1 plus. Okay, our formula says x squared, but what you need to realize is that x is just the angle here. So what's our angle? Now we have to do chain rule. That's the derivative of the outside with the inside staying the same. Times derivative of the inside. How am I going to do the derivative of x squared y? What do we have to do?
Wait. Hold on. I thought you had to do
So I'm talking about the derivative of the inside right now. The
Yeah, but I thought you kept it the same.
I did. Right here.
Oh, you just keep it same in the bottom now?
Yeah, that's for the derivative of tangent inverse, the derivative of the outside.
So you don't have to write like times x squared y?
It's times the derivative of the inside, so that's where we're at. We need to do, to finish our chain rule, the derivative of this inside piece.
What is the thing where you, what is it called when you do that, like the derivative of the outside and then you keep the inside the same?
Chain rule, which is what we're doing right now. The derivative of the outside. So the derivative of tangent inverse is this thing.
Yeah.
And we kept the inside the same. I kept it as x squared y.
So you just don't put it on the outside now?
Times derivative of the inside. So now I'm getting ready to do this derivative of the inside.
Okay. We'll just hope I understand later.
You're saying all the right things.
I just don't. I thought that like when
Okay.
you do the derivative.
All right, let me ask, think of it this way. If I said cosine x squared y, and I wanted the derivative. The derivative of cosine is
Sine.
negative sine. Inside stays the same.
Yes.
And then we do times derivative of the inside.
Yes.
Okay, this whole mess that I have up here right now, this is just the derivative of tangent inverse. That's the outside. That's like my cosine right here.
Okay.
So that's
so
all.
then don't you have to put times?
Yeah, which is what I'm doing.
No, not the derivative. Like, why don't you do this? Why don't you do this? And then now times the derivative. Like, why don't you do that?
Okay. Here, so but here it's not sine times x squared y, it's sine of that. The x squared y right here. That's where
So these are totally different?
yes, because these are inverse functions, which changes it.
So
That's why
it's-
we have to use these
So it's
derivatives.
tangent times.
It's tangent of that.
What?
But the whole derivative goes to this, and that little x right there is what these equations that I've already have this. So times where your x squared y goes through here, that's it.
I just don't get it. If you just keep going, maybe I'll get it. And if
I
don't,
know
then
what
it's fine.
your hang up is. I'll come back to that and explain. Sit down in a minute and explain it. I know where your thought is right now. I just need to figure out how to explain that piece. Okay, so we're doing chain rule. Derivative of the inside. X squared y. That's a product, right? So we have to do product rule. So product rule says derivative of the first. So derivative of x squared is 2x times the second, which is y, plus the first, which is x squared. Derivative of the second. Derivative of y is so that's the derivative of the left. Now let's go to the right. Derivative of x is 1 plus xy squared. So we have to think product rule here. So derivative of the first is 1 times the second plus the first times derivative of the second. Derivative of y squared is algebra wise, this one is kind of ugly. So let's go through, we're going to distribute. So we have 2xy over 1 plus, can I go ahead and make this x to the 4th y squared? If I discard those pieces. If I distribute it to this, it gives me an x squared over 1 plus x to the 4th y squared dy dx. What now? Okay. So let's move on with this dy dx. Now what? Step to get dy dx by itself is divide. Now, this is really ugly, the fraction and the fraction. We can clean all that up. If you look at my answer key, I did. But I'm more worried about the calculus than the algebra here, so if you stopped at this point, that would be okay. Okay. So, the homework you had yesterday, and I'm sorry, there was a bit of a discrepancy. I think when I wrote it on the board, I didn't put number 17, but I don't know that I really drew attention to that, so I apologize if you're stuck on 17. I think I talked about that with most of you, but I just worked that. So you should have already done up through problem 36. So that leaves just a few for you to finish. You should just have 5 problems left. This is due tomorrow. And I'm also giving you a little bit of extra time right now because you have that project that's also due on Monday for extra credit.